Hey everyone, in this video I want to provide how to study for and study CRAM for the new AZ-700, the Designing and Implementing Azure Networking Solutions exam and certification. I took the beta of the exam this week to get an idea of what was involved, and really I've spent the last 7 days just preparing for this video. It's probably the most amount of work I've ever put into one single video. I hope it turns out useful. As always, if this is useful, a like, subscribe, comment, and share is appreciated, and hit that bell icon to get notified of new content. Now, when I think about preparing for this, I definitely do want to get some hands-on, and the good thing is, for the networking, for the most part, is not really expensive resources. Networks are free. There are some elements I might want to spin up to see them and experiment, then I could delete them pretty quickly. To start off, head over to the AZ-700 page. So this page will give me the instructions, well, how to actually go ahead and schedule the exam. It has the skills measured. So you want to be able to look at this skills outline and basically be able to put a tick next to every single one of these to say, yes, I understand those concepts. I feel pretty good. I can answer questions around them. Now, it is a pretty broad exam. I mean, there's a lot of content covered in here. So I don't have to be a super deep dive expert in any one area. I just need to really understand how do these things fit together and what is their function in an overall solution. Now, the other thing that's really good here is they do now have, and they didn't have this when I took the exam, but I did kind of quickly run through it just to see what was in it. They now have a free learning path. And again, that's going to cover most of the content. Now, what they've done in this learning path is they've essentially taken the Microsoft documentation and cut and pasted it into this learning path. So instead of you having to go and search for the Microsoft docs for the right content, that's what the learning path really is. And there's a few questions to sort of clarify your learning, but for the most part, it's the Microsoft documentation, which I think is a pretty good thing. The documentation is good. Now, for the content I've created in the past, I've created a special AZ-700 playlist. And once I finish recording this video, I'll put this at the top of that. So you can actually go and see that. And what I've done is over the years, I've created a whole bunch of content around all the different areas. So I have videos around the networking and then all of the different topics that are basically in the exam. I've already got videos about them. I'm not going to keep referencing these throughout this session. You can just go and check out this playlist. You can go and look at those. YouTube only allows me to add, I think, 5 kind of cards in the top corner that link to particular videos. So I'll target some of the primary ones, but obviously I can't link to all of them. I've got too many videos, but go and make sure you check out the playlist. It's in the description. This video will be part of it, and review that content. So look at the Microsoft Learn material, watch this study CRAM, and then ideally go through the various videos. I have no advertising on my channel. I make no money from this. This is me trying to help out. So you're not going to get interrupted or bombarded with other stuff. Now, in terms of the actual exam, it was 2 hours. I had 59 questions. There were a couple of case studies at the start. Remember, the case study is, hey, here's the scenario, multiple pages, maybe where we are today, business requirements, technical requirements. And then those same artifacts I used to answer a number of questions. I think I had one case study that was 4 questions, one case study that was 7 questions. So that makes up a chunk of that total 59 questions. Then the rest of them, some of the questions where it has a certain kind of scenario, and then it said, does this solution meet the requirement? And it will have exactly the same thing 3 or 4 times. It just changes how they would solve it, and you can't go back. So it's asking you, hey, we would do this. Does this solve it? And then once you've selected that and move on, I can't go back because the next answer maybe would give you a hint and change your previous answer. And then there's just a whole bunch of regular questions. Hey, what would I use? Which steps would be required? Put these steps in the right sequence. It's those types of questions. So that's the exam. 2 hours, 59 questions. I had plenty of time. I think I did it in sub-hour. Obviously in the beta, you don't get your result yet. But it really wasn't that bad in terms of the content. There was nothing super deep that I thought was ridiculous. It kind of was logical for the most part. Okay, so have that cup of coffee or whatever your beverage is, and let's actually get down and start thinking about the actual review of all the content. Now I'm going to go pretty quick, I have to. I'm covering a huge number of things. So the first part, I want to kind of dive into just the basics. And when I think about the basics, obviously we're going to start out with a virtual network. So we have this concept of this virtual network. And I can have multiple virtual networks. I'm not bound to just one or anything like that. And a key point, a virtual network is it exists within a certain subscription and a certain region. I.e., if I have multiple subscriptions, one virtual network cannot span that. If I'm deploying to East US and West US, I would need a virtual network in each of those. So a virtual network exists within a specific region, within a specific subscription. It cannot span regions, it cannot span subscriptions. So that's really kind of a key point. Now it is a regional construct, i.e. it exists in the region. If I'm in a region that supports availability zones, those are distinct data centers with independent cooling, power, communications. In your subscription, typically you would see 3 availability zones. My virtual network spans all of them. So even though there might be like 3 availability zones, my virtual network is not pinned to a certain availability zone, it is still a regional resource. And then what happens with the virtual network is I put resources into it. Virtual machines, AKS environments, app services, many other types of resource that we will actually explore. Now my virtual network is a layer 3 construct, essentially. It understands IP, it's not layer 2. There is no concept of VLANs in an Azure virtual network to maybe segment traffic. And there are other constructs I use for kind of micro segmentation. So because this IP, most of the time we're really dealing with kind of TCP and UDP. And there's ICMP, I can do echo requests within there as well. I cannot do broadcast. I cannot do multicast. I cannot do GRE encapsulation. This is all software-defined networking. Azure is using those things itself. So I'm really thinking about, hey, layer 3, IP, TCP, UDP. And what I'm going to have is this virtual network is really defined as one or more private IP blocks. Now I'm saying private IP, i.e. the RFC 1918, the 10.172.16.192.168. Those IP ranges, but they don't have to be. If I have some public IP block, I can bring those to Azure, but they are still going to be considered private IPs, i.e. they will not be accessible from the internet. So when I think about what is the virtual network, I'm going to add one or more, so I can have multiple blocks. I'm going to have IPv4 CIDR ranges. Remember, CIDR range is that kind of 10.1.0.0/16. I have other videos on IP basics if you're not sure what kind of CIDR ranges is. And again, I can use the RFC 1918 and others. I'm not restricted to those. So I'm going to add one or more IPv4. Now, optionally, but I don't have to, I can add 0 or more IPv6. It is always dual stack. I cannot do only IPv6, but I can optionally add IPv6 if I actually want to add it to there. Now, if I add IPv6 to the virtual network, at least one subnet has to have an IPv6 range as well, but they don't all have to have it. Which brings me on to, so within the virtual network, just like a real network, I divide it into subnets. So I can absolutely think about, well, within this, I'll create multiple subnets. And essentially what happens is those subnets are a segment of the IP space. So I might have kind of subnet 1, subnet 2, and I can give them names. They don't have to be called subnet 1 and 2. I can give them proper names. And so these subnets they have a portion of IPv4 CIDR range. This has an IPv4 CIDR range. And again, optionally, if I gave the virtual network an IPv6, they can optionally have an IPv6, which will always be /64. So because of the way some equipment works with IPv6 and because of how huge the address space is, I'll always have a /64 if it's IPv6. For the regular subnets, I can pick the subnet size. And once again, notice subnets are spanning the availability zones as well. Subnets are not pinned to a particular availability zone. They are regional as well. So it's another important point to realize. These IP ranges of the subnets have to come from the IP range of the virtual network. They cannot overlap. And when I'm picking my IP ranges, even with other virtual networks, with my on-premises networks, I don't want them to overlap. If they overlap, well, for normal kind of communications, it won't work. I won't be able to connect those networks together unless I do some kind of network address translation, which is generally pretty cumbersome. So I need unique CIDR ranges for each of these kind of constructs. And we can see this. If I jump over to the portal kind of super quickly, if I look at my virtual networks, for example, I have a whole bunch of different virtual networks, but you'll see the address space I have here, but notice I can add additional ones. So yes, I have this address space when I created it. I did a /16, but I could add additional ranges now if I wanted to. I could add IPv6 address ranges to that. And then I have subnets, which are a portion of that space. And notice I'm doing some /24, some /28s. The smallest is a /29. And you can kind of see that right here. Now notice that /29 gives me 3 usable IP addresses. And you might say, well, that's kind of strange. A /29 should actually give me more IP addresses than 3. And that's empty. Now the reason for that is just ordinarily with TCP. If we think about, let's pretend this is a /24, so it's very easy. On the host side, it's 0 through 255. Well, we always lose kind of the .0 and the .255 because the .0 is kind of the network address. We generally don't give that to anything. And the .255 is kind of that network broadcast. So we can't use that either. But then what happens is Azure takes the first usable address as kind of this default gateway. And then it uses the next 2 for DNS purposes. So you can see I always lose 5 IP addresses from whatever range I create, which means the smallest is a /29, which equals 3 usable. So that's kind of the point on that. So they're the basics around kind of that virtual network. And again, if I have IPv6 on the virtual network, I have to have at least 1 subnet. And then I put resources into these subnets, whether it's a VM or AKS or app services or firewalls or NVAs, doesn't matter what it is. There's some resource which will, via a NIC, and the Azure Resource Manager and Network Interface is a resource as well. It will get linked to a certain subnet, and it will get its address through DHCP. So the Azure Fabric provides that DHCP service. It's always going to use that, except in some very fiddly, which you don't really need to know. If I have multiple IPs on a single configuration, I might have to do some static config. But it's going to get that IP. Now, these are all private, remember. These are all kind of private IP addresses. Those IP addresses are dynamic normally, i.e., hey, I need an IP address, well, here it is. If I deprovision that resource, i.e., I stop paying for it, well, the next time I start that VM up or whatever that is, I might get a different IP address. I can also say, hey, I want it to be static. So that's kind of like a DHCP reservation. So when I restart my resource, I would still get the same IP address, even though I was deallocated. And that's done on kind of the per resource level. So if I was to quickly look at like a virtual machine, I look at its network configuration, I can see it has a network interface card. And I can see on that network interface, we have IP configurations. And within there, I've got this IP config. And this IP config we can see is static assignment. And that's kind of the key point. And I've given it the particular IP address I want it to always get. So if I had resources in Azure that always need the same IP address, maybe it's a SQL server or a domain controller, I can absolutely make that happen. So that's kind of the fundamentals when I think about, okay, just the virtual network. So make sure you don't have overlapping IP ranges. You can add ranges. I can resize things if they're empty. So I can resize, but I have to empty it first. So ideally, get your planning done the right way. So that's all private IPs. Okay, well, that's great. Then we can think about kind of public IPs. I cannot bring my own IPs to Azure. If I own a block of public IPs, I can't use them as public IPs in Azure. Azure has its own public IPs that are regional. So I can think about, hey, I have kind of a certain region in Azure. It could be like East US or East US 2 or West US, whatever. When I create a public IP, it exists in that region. I can't move it to another region. I have to create a new public IP. Now, by default, it's kind of an interesting point, resources in Azure can get to the internet. I don't have to do anything special. I can do an outbound connection and I can get the stateful, the response back to me. I don't have to do anything special. The exact mechanism varies depending on, hey, does a resource have its own public IP? Is it behind a load balancer that has a public IP? Depends on the config. But fundamentally, they can all get outbound to the internet and get the response back. But what about if I want to offer services to the internet? I actually may want to make a web server available. So I think again, okay, well, remember I have that virtual network. And remember that virtual network has that private IP space. And then within there, I have a certain subnet. And we'll just say I have some kind of resource. It could be a VM with a NIC attached. It really doesn't matter. So remember that has a private IP. That private IP is from the IP range of the subnet it is in. It can do outbound, can't receive. So what I have to do is I have to create a public IP. This is a resource in Azure. Now there's actually 2 SKUs for a public IP. So I can think about, well, there's a basic SKU, and then from the basic we can also build on there is a standard SKU. So I have 2 different types. Now that basic SKU you get a certain amount free. This can be dynamic or static. I.e. again, if I kind of stop using it and then start using it again, I might get a different public IP. It is open by default. It's just going to let everything kind of come in. There is no availability zone support. And what that means is if I was kind of having certain resources, I can't make that resilient against maybe a data center failure or make it resilient across different zones or pin it to a certain zone. It has no concept of that. Then we have standard. Standard is static only. It is locked down by default. And we'll talk about something called network security groups later on. So here I would use an NSG to allow things. Here I would have to use an NSG to actually lock that thing down. And it has AZ support. And what you'll find is there are a lot of services that require a standard SKU, public IP. And if I have certain types of resource like a load balancer we'll talk about later on, the SKUs have to match. So if I have a basic load balancer, I have to use a basic public IP. If I use a standard load balancer, I have to use a standard public IP. So they kind of go hand in hand. So we have these two different SKUs available to us. And then what I essentially do is I have to use that public IP. Now, yes, technically, I could link that public IP to a particular resource. That then becomes kind of this instance level. So it's just, the resource doesn't really know it has a public IP. It all gets converted by the fabric, but it links directly into that resource. But most of the time, if we're doing this kind of public IP, it's because I'm offering a service to something. So I want it to be resilient, I want it scalable. So generally, this is not kind of the thing we want to do. Instead, we would have some kind of load balancing solution. Now, depending on what we're doing here, this might be a layer 4, i.e. like TCP, UDP, might be layer 7, like HTTP, HTTPS, HTTP2, we'll talk about that. And this load balancer would link to a whole bunch of different resources, and I would link the public IP as the front end configuration of that. And that is generally kind of what we'll typically do with public IPs. Public IPs are used by a whole bunch of things. VPN gateways, firewall solutions. They're massively used. Now, the other thing I can do is a public IP is a single IP address. What about if I know I'm going to need multiple public IPs and really I want them to be contiguous, one after the other? So the other thing I can actually create is a public IP prefix. So public IP prefix is that contiguous block that I kind of get in advance, and then I can use them from that block. Some resources I can just assign the prefix to. Like a NAT Gateway, I can give it a prefix, and it will kind of go through the IPs and use them as I need to. So this is a contiguous block of public IPs. So that's how I can think about those. So two different SKUs. That's how I can then obviously offer things from the internet to actually get to certain services. And likewise, if I have a public IP, I might then use it for the outbound as well. There were services like Azure Firewall and NAT Gateway that would actually use it to snap traffic on the outbound. And we're going to talk about those later on, so don't worry about that just yet. Okay, so that's all well and good. We have this virtual network. We have public IPs. And I said the virtual network was bound within a region and a certain subscription. So what about if I have multiple regions? What about if I have multiple subscriptions? What about just if, hey, I need different virtual networks for different regions? Well, I can peer them. So what we can actually do now is, well, I can do peering. So I can absolutely imagine the idea that, okay, I have VNET 1. And VNET 1 is a certain IP address space. Let's say this is 10.0.0/16. So that's kind of the important, those first two blocks. And then let's say we have two other virtual networks for the time being. I've got a VNet over here, call this VNet 2, and I have another one over here, VNet 3. And remember, if I want to connect them, they have to be unique IP ranges. So we'll say this one is 10.1/16, so it's those bits that are important, and we'll say 10.2. So those are the important parts. So because they're unique ranges, yes, I can connect those. And what we might say is, well, let's say this is kind of region 1, i.e. that could be West US, and this one happens to be in region 2. Maybe that's East US. Has really no bearing. So what I can do from here is I can peer them together. So on the Azure backbone, say, hey, I want a connection between these VNets. Now before this, we'd have to do like a site-to-site VPN. Then we were restricted to the speed of the VPN gateway. VMs couldn't operate at their native capability. We lost stuff with that. With peering, I don't have any of those problems. It's using the native Azure backbone. So because these are in the same region, this is just VNET peering. Because these are in different regions, well, this is global VNET peering. But it doesn't really change very much. It's going to kind of work the same way. Now, I cannot peer across clouds. And what I mean by that is there's more than one Azure cloud. There's the commercial cloud that most of us are using. Then there are sovereign clouds. China, US Gov, Germany. I cannot peer VNets, for example, commercial to China or to US Gov. I can only peer within the same cloud. Now, a peer is actually created in each direction. There's a bit of permissioning I need to actually peer to a VNet. There's permissions I need to establish the VNet outbound. My deep dive video on that, I've actually got one on kind of peering, overview of VNet peering. I go into exactly what those permissions are, so I'm not going to cover that here. But there are permissions I need to do. If it's different subscriptions, I have to kind of authorize that peer to actually complete. But essentially it's made up of two peering connections. Once I do those peerings, there are some kind of special tags in virtual networks. One of them is called virtual network. And I might think virtual network is the IP space of my virtual network. It really isn't. Virtual network is the known IP space. So when I peer, virtual network now includes the networks I have connected to. So if I've peered to these two VNets, virtual network, the tag, which we're going to talk about, now includes 10.1/16 and 10.2/16 as well. That's important when we think about certain rules because if I'm using virtual network, it now applies to these as well. So important point. So IP space cannot overlap. I cannot peer if the IP space overlaps. Another important point. Let's imagine this is a hub, and these are spokes. So this spoke has peered to the hub, this spoke has peered to the hub. Can they talk to each other? No. It is not transitive. Those cannot talk. If I want them to be able to talk, I would have to add a peer between these two, i.e., I have to create a mesh network. The alternative to that is route via the hub. And what I mean is there are certain appliances I could put in this hub right here that would then enable it to be the next hop and could route on their behalf. So there are ways to do that. For example, let's think about this for a second. I could have something like in here, I could have Azure Firewall or just some kind of network virtual appliance. And then I could tell these, hey, use this appliance to actually get to each other. So the way I would do that is I could use something called user-defined routing and say, hey, if you want to get over to there, go that way. And I would do the same to get back again. So there are ways to do that. Now also consider, within this hub, I probably have connectivity. I probably have kind of a gateway subnet. And I have some gateway devices. This could be site-to-site VPN. It could be ExpressRoute. And we're going to talk about what exactly those are. So these are kind of these, maybe it's active passive if it's VPN, or it could be active active. ExpressRoute is always active active. But I have these devices that have kind of connectivity to my kind of on-premises networks out there. Now, what if I want these spokes to be able to use that connectivity via this hub? And I can absolutely turn that on. So there's a configuration I can actually do. So I remember I said there's kind of two peerings, two kind of directions on this. So what I'm going to do is on this side of the peer, there's a flag I can do that actually lets me say, hey, allow gateway transit, i.e. let them use my gateways. And then on this side, I'm going to say use remote gateway. So that's on this side of the connection. So allow gateway transit on the hub side, let them use my gateway, send the BGP routes through, use the remote gateway. Hey, on these connections, let's actually use that. And if we go and look super quick, if I was to go and just look at a virtual network, so I'll look at my hub. So on my hub, if I looked at the peerings, so this is from me to, let's say, East US, what I would make sure is use this virtual networks. That would be the setting I would need to make sure I have turned on. So that in the PowerShell would be allow gateway transit. And then on the peering of the spoke, if I looked at its connection, what I would need to do, and I can't do that because I've not got it turned on the other connection, I would do use remote virtual networks gateway. So that would then let those spokes actually go get the routes advertised via BGP of that connection and then use it. So the spokes would now be able to get to these, whatever that on-prem is on the other side of that VPN or that ExpressRoute, because they're going to use the gateways of that. I can only use one peer's remote gateway. I could not have another hub and use that remote gateway as well. It's only one of them can be selected to actually do that. And if I have a gateway in my local VNet, I can't use a remote gateway. I'm only ever going to use my own. Now there was actually another setting, and it was allow forwarded traffic. And that's kind of important if I do have some kind of network virtual appliance in the hub, and I want traffic to be able to flow via it, because this has to basically accept traffic from here via this connection. So there was that option on the peering as well, and it was this setting here. Allow forwarded traffic from remote virtual network. So that would say, hey, I'm going to let that hub network send me traffic from someone else, i.e. it can act as that kind of forwarder. So I mentioned something about kind of some special routing. If I actually wanted to do this, I said this user-defined UDR thing. And if you think about it, by default, a virtual network has a set of routes. There are routes it knows just because of its IP space. The rest of the RFC address space is kind of black holed. It knows everything else to go out to the internet. And I can see those. If I go and look at a network interface card, so if I just go and pick any kind of virtual machine in my environment, and if I go and look at its networking and look at its network interface card, so I'm selecting its NIC, we have this effective routes option down here at the bottom, and these two are actually both super useful. Effective routes to see the routes it knows, and effective security rules when I start doing things like NSGs, network security groups, to see what rules are impacting it. But if I look at the effective routes, we'll see a whole bunch of different routes. Now, there are some that are just built in, and then there are other things that will get added. When I have things like a VPN connection or an ExpressRoute, well, there will be other routes added for the address space on the other end of that connection. So we can see here, well, there's a default route for my local VNet. Kind of see that. There's a default route, 0000/0 goes to the internet. And then there's a whole bunch of ones, well, black hole, the rest of kind of the RFC space. There's different rules about that over here. Then there are some other special ones around sort of the Azure itself. And that's actually an important point. I said you can kind of use pretty much any set of IP addresses you want. There are actually a set of IP ranges you cannot use. So I said, sure, use RFC, you can use other address spaces, but you cannot use these ones. I said you can't use multicast or broadcast, but it also blocks off some other IP addresses because they're just not allowed as part of Azure. So there are other ranges you can't use. But I have these default routes. And again, other things will get added into them. Like I've added peering. Well, now it knows there are these other IP spaces over here that are used for peering. There are other ones about certain service endpoints, and I'll talk more about that later on. There are private endpoints added in. I would see things for virtual appliances. I would see things for gateways. There's this whole bunch of default routes that kind of just exist within the virtual network that get populated to the network interface cards themselves. But I may want to change that. I may want to add additional routing. And for good cause, maybe I've got like network virtual appliances. I want to change the type of traffic I'm actually doing and sending over these things. So I can create route tables. So I can think about, okay, I can create this route table, and we think of this as this user-defined routing. And a route table is really just a set of routes, the routes I'm going to define. Now in this case, I might say, look, I want to define a route, how to get to that spoke over there. Now that particular NVA, it would have a certain IP address. Maybe it actually has an IP address of 1.4. That's the IP address of that Azure Firewall over there. So I want to say, look, to get to this address space over here, so to get to 10.2, my next hop is a virtual appliance, and its IP address is 10.0.1.4. This is, remember, a software-defined networking. My next hop doesn't have to be an IP address on my local subnet. It can be an IP address actually on a different subnet, even a different network. It's not like traditional networking, how we used to think of it with bits of copper wire and actual physical connections. So I create this route table. If I had 0.0.0.0/0, I'm setting a default route, i.e. send everything to this virtual appliance, and I could do that. And then what I do is within here, I have subnets. So I have a certain subnet. I link the route table. Oh, let's change that color. I link it. The route table has to be in the same region as the virtual network when I create those things. And then I would do exactly the same on the other side. I would have a route table here as well. This one would say, hey, to get to 10.1.0.0, I would go to that same virtual appliance, and I would link it to the subnets I wanted to go here. So what I've essentially done now is through that, I've configured, hey, you can now get to each other via that virtual appliance. I've added my own user-defined routing to change the default behavior. So I'm linking it. I want to make sure it's symmetrical. I want to make sure it flows in the same direction, especially this is kind of a stateful firewall or virtual appliance. It needs to see the traffic going in both directions. And again, remember, I could look at those effective routes as I was showing here to actually see what is happening. So if I kind of looked at this, and actually if we look at a different virtual machine, so if I look at my West Central, and it has its networking, and it has a network interface, and look at its effective routes. This actually is using my Azure Firewall. So what I did for this one is I added a default route. I want everything to go via particular Azure Firewall I have defined. So here you can see this user-defined route here. So I'm overriding the regular 000/0. I'm sending it to my virtual appliance. So that means, hey, everything go via this particular one. Now, I also have another VM in the VNet I want it to talk to. It also has a route table, but it only sends traffic through that's destined for the subnet of that West Central US. So it's using the same appliance in that same hub virtual network. And I go into detail on this in my Azure Firewall video, so I'm not going to deep dive here. But the point is I define these various routes I want, and they then take effect on the various devices that I actually have in the environment. And there's a bit of work it has to do to go and work out the effective routes, but it's going through, and all I'm going to see is a /16 user-defined route that's actually applying on this network interface card. When this wakes up, it would show that to me. But honestly, I don't want to sit here waiting for this. If I go and look at the route tables themselves, the whole point is this was the one it had. And we can see here, this is what you would have seen. 10.3/16 goes to that same virtual appliance. And I can just add multiple routes. So I give it a name, the prefix, and then what is the type of hop? Is it a virtual appliance? Is it to the internet? Is it overriding the default virtual networks? Is it a virtual network gateway like site-site VPN or ExpressRoute? So I can add multiple routes, and then I link it to one or more subnets. But again, I can only link it to VNets in the same region as the route table. So if I'm doing things across multiple regions, I'll need a route table for each of those. So that's kind of a key point in how those things really all fit together. So that's one element when I think about, hey, I'm connecting things together. I also talked as well about, hey, if I want to get to the internet, well, there's this public IP. If I have one, if the load balancer I'm behind has a public IP, I'll use it. But I may want more control. Now, there are mechanisms I can do through Azure Firewall, through the load balancer, but it's actually a dedicated service. So there's actually something, so that was kind of the peering, there's actually something called NAT Gateway. So with NAT Gateway, we'll use a color I haven't used that. So NAT Gateway. As the name suggests, this is focused just on the outbound NAT connectivity. So what I do is I create this NAT gateway, and what I do is I have public IPs or prefixes that I attach to this that is basically focusing and listening on. These have to be standard SKU. Remember I talked before about different SKUs. Some services require a certain one. Has to be standard SKU. And then what I'm doing is from that NAT gateway, once again, I link it. So I go and link it to particular subnets. Again, in the same region as the NAT gateway instance. So what happens is now their outbound traffic to the internet will go via the NAT gateway, and the NAT gateway performs that SNAT, source network address translation. It's super, super efficient. Normally we might struggle with port exhaustion. The whole point of SNAT is I have this private IP range. They're not usable on the internet. So these devices essentially use a port per unique session, TCP or UDP. Well, if I have tons of people connecting, there's only so many ports per IP address. So I can run out. So by giving it a prefix or multiple public IPs, it lets it scale even better. I think it's 16 IPs, but you should check that number. That's kind of in the top of my head. I'm thinking 16, but could be wrong. And that's in total. So if I had a prefix of 8, that counts out of those 16 that I can do. It's standard SKU, and it's also IPv4 only. I cannot do IPv6 on this. Each public IP is 64,000 concurrent connections. So times that by 16, That's a lot of connections through one NAT gateway. It can be pinned to a certain zone, so it can be zonal or regional, but it cannot be zone redundant. So those are the two options. I can pin it to a zone, or it can just be deployed to the region. It works with things like the standard load balancer. It actually does not work with basic resources. So if I try and pin it to a subnet with basic IP, public IPs or public load balancers, it will not work. It'll actually complain, it won't let me link it. But then any traffic I'm doing outbound will go via this NAT gateway. Now it is intelligent. If I had services that had maybe a load balancer and it had requests coming in, so we think about this picture over here, if things were coming in to the load balancer, the responses would still be sent out via the load balancer. But net new outbound connections to the internet would go via the NAT gateway. So it is intelligent. It's not going to break flows by coming from different IP addresses. It will work with the other things you actually have. Okay, so next. Public IPs, public IP outbound, all good things. And again, NAT gateway is super simple to actually deploy. The next big thing we typically have is DNS. By default, the virtual machines I have, or any resources in a VNet, are using Azure DNS. So if I go back again, DNS. If I have that virtual network, as part of the virtual network configuration, there's actually the ability to define my DNS. Now by default, it will use Azure DNS, or I can use custom. I have a choice for that. Now the default Azure DNS will provide me name resolution for the resources in the same virtual network. But if I'm going across virtual networks, I won't get any kind of consistent name resolution. I can also define custom DNS at a per NIC level if I need to override it just for a couple of virtual machines. Now the way this really works behind the scenes is, hey, we have these resources that get defined. And the way its DNS works is there's a special IP address. So there's this 168.63.129, oh, terrible writing. 129.16. That is always the IP address for Azure's DNS. So this is the Azure DNS endpoint. That's where I go for anything that is Azure DNS. So that would be if it's going off and then querying something on the internet, it will be saying if it's going internally. Now, what if I want a custom name? I want different names internally, but I want them to work across different zones. Now, I could have my own DNS servers. I could have Active Directory DNS servers. I could have some custom Linux thing, but I want it to just be a native part of the platform. So what I can actually do is I can create Azure private DNS zones. So I create this Azure private DNS zone. Now that is a certain name. That is whatever I'm going to have, name.com or whatever I want. It's a certain name for that zone. Now within this Azure Private DNS, I support a whole range of different types of records. So I can have things like A records, CNAME records, text records, pointer records, MX records, SRV, SOA. There's a whole bunch of different types of records I can have within that. And I can manually add those or I can actually have kind of this auto creation of those. Now the way that auto actually works is I have my virtual network. I actually have multiple virtual networks. But I link the virtual network to Azure private DNS zones. And there's two different modes for those links. Each virtual network can link to one only one Azure Private DNS zone for registration. Only one. Now, I might have other Azure Private DNS zones, name 2, bob.com. I can also link to those for resolution. I.e., I can go and look up records. I can link to up to 1,000 for resolution purposes. So I can link to one Azure Private DNS for the resources that get created, VMs, AKS worker nodes, virtual machine scale set, SQL managed instance. It will register those names into that zone. So I'll get vm1.name.com, vm2.name.com. And obviously I would also use that for resolution as well. I want to be able to look things up as well. And then if I have other zones, name 2, name 3, I can link to those, but only for resolution. My resources will not create records. And this makes sense. I'm not going to create VM1 into 8 different zones. So I can link to 1 for registration, 1,000 for actual resolution purposes. So now I could look up, hey, www.name2.com or whatever that might be. Now those zones themselves, so each of these zones, now firstly, these are global resources. I can use them across different regions. And for each zone, it supports 100 VNets that are doing registration to it. And it supports 1,000 VNets for resolution. Which again makes sense. I might have 5 different VNets. I want them all to maybe register the same name.com. And they can go and look across. So a single zone can have multiple virtual networks registering records into it, and up to 1,000 resolving from it. But a particular VNet can only register records into one, but it can use 1,000 for actual resolution. So hopefully that makes sense. And this, when I use Azure DNS, it's using that for the actual lookups. So that's how I'm actually resolving. It's using that 168.63.129.16. This will only work in Azure. So one of the things you'll sometimes see is if I'm on-prem and I want to use Azure Private DNS, I can't. This IP address will not work. I would have to have some kind of DNS forwarder as a VM that it talks to, its private IP, and then it goes and talks. That VM in Azure goes and talks to this. Now I can also have, that's private DNS, I can also have Azure public DNS zones. Now obviously for a public DNS zone, these are all going to be manually added. I'm not auto-registering anything to these. This is really host records or IPv6 host records and aliases. Once again, it's going to be a certain name, whatever that might be, name.com, and I have to be authoritative, probably spelled that wrong. I have to be authoritative for that zone to be able to make that on the public. It has to actually point to Azure DNS for that to actually work, but then that endpoint will resolve to those as well. So I can use those from my resources internally. So if I want something to be accessible from the public internet, I create an Azure public DNS zone, but I have to prove I own that name. There are records, you create like a text record that proves I own that, and they'll go and check, hey, you did create that text record. That means you have access to create records in it. So, okay, we'll go and move it to here. Obviously, private DNS zones, I can use whatever names I want. It doesn't care because it's only usable from within that virtual network itself. So that's how I can use the DNS things. So these are all really right now all about just stuff in Azure itself. What about hybrid connectivity? Hey, I want to get to other things. So there's many different types of hybrid connectivity. technically from on-prem, I could connect to things via an internet connection. I could expose it to the internet, but that's generally pretty terrible. I don't want to expose things to the internet. So instead, remember those private IP addresses via resources? I want to be able to get to those private IP addresses, which means connecting my virtual network to my data center, or maybe some virtual network on another cloud. And the way we think about starting with this is kind of a VPN, a virtual private network. So straight away, I'm going to think once again, we're just going to start with this virtual network. Nearly everything we do, I'm going to start with a virtual network. I'm going to have to drink, I'm thirsty. This is going to be a super long session. You'll probably see me drink quite a few times. So I have this virtual private network. Now, remember always, I don't want to overlap the IP ranges. This VNet has a certain IP range. And the first thing I have to do is I create a gateway subnet. Now I get to name it. And what actually happens is it's going to create this for me. It's going to use kind of an IP range. Now, the minimum is a /29. The recommended is a /27. And the reason the 27 is recommended, and sorry, it's not you get to name it, you can pick the IP range it's going to use, is if I only use site-to-site VPN, a /29 is fine. If I only use ExpressRoute Gateway, a /29 is fine. If I choose later on to coexist and I want VPN and ExpressRoute, I need the /27. And I remember I can't resize if there's things in it already. So unless you're really, really short of IP ranges, do that one. Do the /27. But if you saw kind of maybe a question, it's like, hey, you've got a /29, VPN, you're going to add ExpressRoute. It's not going to work. You're going to have to delete the gateway, make it a /27, add the gateway back, then add the ExpressRoute. So that's going to kind of be a key thing. Now, there's actually two types of VPN gateway. So what's happening is my gateway is going to deploy into here. So into that VNet, I'm going to kind of get these gateways. And there's two types. Now, there's actually a huge number of SKUs, massive number of different SKUs that really relate to kind of the generation. There's a V1 and a V2. There's even a basic. And it's really about the speed, how fast they're going to go. But we can really break this down into the basic SKU, which is really kind of this legacy. Again, I'm going to do the frowny face. I really don't want to be using that. And then we kind of have everything else. These kind of Gen 1 and Gen 2. And they're the ones we kind of want to use. And the reason is this is super restricted. So this is something we call a policy-based. You'll also hear this called static. And the way this basically works is it can only have one tunnel, i.e. a connection to one network. It cannot coexist with ExpressRoute. It cannot do point-to-site VPN. And the way these work is essentially it encrypts the traffic first, then sends it to the tunnel, which has kind of an ACL of which IP address it allows. So because it's doing that encryption first, I can only have one tunnel. Whereas all of the others are route-based, i.e. dynamic. And what that means, I can have n number of tunnels, because what it's basically doing is it directs the traffic to a tunnel and then encrypts. So I can have different kind of encryption depending on the tunnel I'm sending to. So it gives me that flexibility of multiple tunnels. I can have both ExpressRoute coexist. I can also have point-to-site VPN if I want it. So it's just kind of this richer option. It supports things like I can do BGP optionally. And I can do active-active configurations as well if I want to. So it deploys these multiple gateways. They can actually both be active and both establish tunnels to give me kind of that better resiliency if there's actually a problem. Now there are a massive number of SKUs. If we jump over quickly, so here we can see, hey, this Gen 1, we have basic, this one. So it doesn't support BGP, it's not zone redundant. It says max 10, but that's only max 10 if it's running in a dynamic mode. So it does support that as well, but it's actually the only one that supports static. Then there's this whole bunch of VPN Gateway 1, 2, 3 AZ versions, then there's Gen 2 versions. And you can see things like the number of tunnels, vary, point to site if it's BGP zones, the speed varies kind of greatly. You can kind of see the different speeds. Now this is the total speed it supports across all of the different tunnels. What we find is actual for an individual tunnel, it's kind of this 1 gigabit per second because it goes through a single core. So no matter how, yes, I can have multiple, these get bigger, so I can support more tunnels, but the actual a particular tunnel is still 1 gigabit per second because it goes through a single core, and that kind of maxes out a single core. So I can think about, okay, so I've got different gateways. Actually, if I go back to that document for a second, it does kind of go through different requirements. It talks about the encryptions it can use, feature sets. So remember, the basic SKU can do route-based and policy-based. And then remember that policy-based is kind of stressing one connection. And then everything else, they're only route-based. So it does kind of talk about those differences between them. I cannot convert from a basic SKU to one of the other SKUs. I basically have to delete the basic and then recreate it. The others, for the most part, I can kind of convert between them. So how am I using these? So I create the gateway. So I create as a resource the VPN gateway resource. That's kind of step number 1. Well, then what happens is, if you think about it, I have my on-premises. And this is a certain IP space, so I have some CIDR range that represents the IP space on-prem. Let's say CIDR 1. And this is obviously an IP range up here. Let's say this is CIDR 2. And then I'm going to have gateway devices. So I have kind of a gateway here. Maybe I have 2. So what I have to do is I then create what is kind of called this local network gateway. So local network gateway is created in Azure, and it represents kind of the public, so these each have a public IP. Now I might not have 2, I might just have 1. Public IP 2. So I'd create it, I'd say, okay, well this is public IP 1 and it's CIDR 1. Now if it's BGP, then there's other things I can do as part of that address config. If I was going active-active, I'd create a second one of these for public IP 2, and it would just be the same CIDR range. So this defines my on-prem connectivity, and then the next thing I have to do out of here is a VPN connection, which is from the gateway. I create a VPN connection, which links to a certain local network gateway. Up here, I have a public IP. Now, if I selected as part of the creation to make this active-active, I'll have 2 public IPs. So this would be public IPs if it's active-active. And then I really control what that configuration actually looks like, because there are a number of high availability configurations. I might, for example, say, hey, I'm going to connect from both of these to the gateway. I might do that. So I've got resiliency if one of these fails. Or I might just have one, but I'm active here, so I connect one of them, pretend that isn't there, to both. So maybe I do that. Or maybe I'm active on both sides, so I have that. So different configurations I can perform, but I have that capability. It's all documented. The learning material goes into detail on all of these, but essentially remember, you are going via these gateway devices. Each tunnel is really 1 gigabit per second per tunnel. So yes, these might support 10 gigabits per second as a gateway, but an individual tunnel is still kind of limited to that number. I wouldn't use this to connect different VNets together, remember, because I'm going to limit it by that tunnel speed. When I'm linking virtual networks together, use the peering. This is a much better, superior speed option for that. Okay, so I'm connecting my on-prem to Azure, and essentially now that they're connected, Azure is an extension of my on-prem network. Now from here, I can go and get to the private IPs of any resource here, and if I do the networking correctly, kind of peered networks as well. It's just an extension of the network. Likewise, things here, all the peered networks, if I'm using the remote gateway, allow gateway transit, can get to things on premises. What about if I just have some individual machine, contractors, remote workers, they want to be able to get in? Well, I can also, and it's really going via these public IPs, I can enable point-to-site VPN as well. Only remember on the route-based SKUs, but I can go and turn that on. So that's giving me the ability for individual machines to actually go and connect to that virtual network. So it's going to create a tunnel. Now there's actually 3 different types available to me. There's kind of this open VPN. Now this is establishing an outbound kind of TLS. So it's using 443, so that should work really from anywhere. And this really works for kind of all clients. This could be iOS, Android, Windows, Mac, Linux. That's generally kind of the preferred thing you're going to use. There's SSTP. Once again, that's kind of the TLS 443, but that's Windows only. And then the third one is this IKE v2, and that's kind of Mac. One of the great things about this, so all of these can use things like CERT-based or authentication. They can integrate with AD. So if I had my regular kind of Active Directory, so I've got my regular AD, they can integrate, but the way they integrate is I have to deploy Radius. So I have to have a Radius server that talks to my AD, so then these can kind of go and query us to Radius. If I have Azure AD, so I'll think about, hey, this is for the OpenVPN only. So I have kind of Azure AD. This can use that. So I can actually, one of the nice things, and then things like conditional access, MFA, can all come into play. Now the only thing to use the OpenVDM with Azure AD, you have to add an enterprise application to my Azure AD. As part of the setup, you'll go to a special URL, and I have to consent and say yes. And when I do that consent, it will add in an enterprise app. So if you see, hey, you want to add OpenVPN, what do I have to do? It's adding an enterprise app to Azure AD to actually make that work. Hey, I want to hook into Active Directory. Hey, I need a Radius server. If your IP address space changes of what you're connecting to, for the OpenVPN and the SSTP, for the OpenVPN and IKE, it will just detect it, but I will have to reconnect. For the SSTP, I'll have to re-download the configuration to actually make it take effect, to learn about those new routes. So that's where I can actually think. But now I've got this kind of complete connection. Remember a key thing though, those connections right here, they are all over the internet. So it's all going over the internet. Latency, I don't know, might be taking a different path, different noisy neighbors, people conflicting with me. So that will potentially vary pretty massively over time. And I may not like that. Now they've encrypted. I'm not super concerned about the security side of it, but maybe I want a more dedicated kind of private connection just for me. So how do I think about that? So that's when we get to ExpressRoute. So I'm going to keep drinking. So ExpressRoute is all about a private connection. So let's scroll over. I have plenty of space. Good. All right. So let's talk about ExpressRoute. So I think of Microsoft. Microsoft has this massive global WAN. It spans the world. It's one of the biggest networks. You can actually see it. So if I go and look, there's a way you can go and explore. So this is a kind of a picture of the Azure global infrastructure. And you can see all these little kind of connections. All of these, Microsoft has all this connectivity, all these little lines. That's connectivity all throughout the world. So there's this massive backbone network. And those blue circles are Azure regions that I kind of talked about. So we have all these different regions all throughout the world. South Central, data support availability zones, got all of those things. And I can see kind of a basic map view as well. So regions all throughout the world, massive set of infrastructure. Now, the way this actually works is there's this massive Microsoft backbone. Fantastic. And then I talked about regions. So I can think, okay, well, I'll draw this great big region. I have a certain region. So this is, hey, I've got region 1. Really doesn't matter. And the way this works behind the scenes is there are these kind of regional network gateways in each region that go and actually connect to that Microsoft backbone network. That's what actually gives it that connectivity. Now, in addition to connecting, and again, there's many, many other regions. So there's like other regions, region 2, 3, etc. Lots of regions. They all connect as well, redundant connections. But there's other kind of points of presence. So there's also these kind of points of presence on the edge. There's a certain POP. And maybe I go and connect to some internet service provider. It could be an AT&T, a Verizon, whatever that is. That's how we get to the internet. An internet is just a whole bunch of different connected networks, and these kind of meet these carrier neutral facilities. Now, in addition to those kind of points of presence, that Microsoft backbone network also expands into these peering points. So we actually have these carrier neutral facilities. So we kind of call these meet me's and peering points. Same thing. And what happens here is that Microsoft network once again expands into a whole array of routers. I'm just drawing 2. There's this whole Microsoft Enterprise Edge actually at that facility. So what we can do is customers, I can think about, hey, I've kind of got my customer network, so I'll kind of draw that down here. So this is my customer. Now that customer might be at a colo, in which case they're in kind of the same building. I'm drawing it as, hey, they have their kind of customer edge routers, and those customer edge routers connect into this kind of meet me facility. It could be an MPLS, so it's kind of more, it's a cloud, but it's this layer 3 MPLS tagged, but it's still basically going to end up as that ISP is essentially going to have a set of routers. So they have kind of this provider edge customer facing. to connect to the customer. And then what will actually happen here is then that provider has an MS Enterprise Edge facing. So those connections get connected through, and then it does a cross connect to Azure. So then I'm going to do this as a magical color just to kind of show magic. Then we get this. At this point, what have you done? You've connected the customer network to that Microsoft backbone network. So that's kind of the key point. And again, I've drawn it as this direct layer 2 connection. Doesn't have to be. There's many different ways this can actually work. There's different models. Could be an MPLS. It can even be ExpressRoute Direct. So if ExpressRoute Direct, essentially the customer has their own routers in here. They're not using a provider, and the customer maps their routers directly into the Microsoft Enterprise Edge. So if I'm a really big customer, I can get these 10 or 100 gigabit per second direct port connections, and then I create circuits on top of those. Now these meet me locations, there's a whole bunch of them. So if I jump over, I can kind of see, hey, look, for Amsterdam, Amsterdam 2, there's different addresses and there's different service providers that operate out of these. So lots of different locations, different providers, shows me kind of the different speeds they're supporting. You'd also see this local Azure region for some of them, not all of them. Some of them it doesn't apply to. And I'm going to explain what that means in a second. But basically, for all of the models, I'm using a certain provider. Microsoft does not provide last mile. Microsoft do not provide the connection from your location to its enterprise edge. You're using someone to do that. Either that's a service provider or you have got your routers in this facility and you're using ExpressRoute Direct. So you can do that. It's always a pair. It's always redundant. It's always active-active. So there's always two connections between you. And that's kind of an important point because I buy a circuit. Even if I'm doing direct, I buy a port, I create circuits on it. So I create kind of this ExpressRoute circuit, and that ExpressRoute circuit is a certain speed. So I buy a 10, let's say 100 megabit per second circuit. Well, it's actually 200 megabit per second circuits. So if everything's happy and working, I'll get double the throughput, and it's full duplex. So it's 100 in each direction on each connection. So I actually get a much bigger throughput than I might otherwise think I have. Now that's great. I've connected my network to Microsoft's backbone network. Fantastic. What can I do? Absolutely nothing. Because nothing's been advertised. I've just connected networks together. But there's no routes being advertised to say, hey, you can get to this VNet or these Microsoft services. Because there's actually two different types of service I can use, two types of peering once I have this connectivity. There's something called private peering and Microsoft peering. So private peering is, hey, I have, oh, don't do that color. Let's get that back out. I have a certain virtual network. Remember that virtual network is a certain kind of IP space within there. And I want to connect that virtual network to my on-premises IP space. So that would be private peering. Microsoft peering would be, hey, there's other types of service in Azure. There's maybe storage accounts. There's even things like Microsoft 365. There's SQL. There's all these different things. I want to use those, but those don't live in a VNet. But I want to be able to get those advertised as well. So let's start with private peering. So if I think about private peering, I have my virtual network. So the first thing I have, remember, I need that gateway. So I have my gateway subnet, and it's going to deploy ExpressRoute gateways. So these are different from the VPN type. They can coexist. ExpressRoute will always take preference. I need that /27 if I want VPN and ExpressRoute. You can actually do it VPN over ExpressRoute. If I want it encrypted end to end, I can do that because this is a private connection. There's no encryption on here. So if I actually want it encrypted, I could do IPsec, I could do a VPN over it, I do have those options, but this is not an encrypted connection. But I get some number of gateways. We don't really see or care about the exact number. There are different SKUs. So if I look at the ExpressRoute gateways, I can see, hey, standard SKU, high performance, ultra performance. And then there's a maximum number of circuit connections. So depending on the SKU of the gateway, I can depend to multiple ExpressRoute circuits. So remember, a circuit is really tied to a certain meet-me. I might connect to different ones, maybe for redundancy, for various purposes. I can actually connect to more than one circuit from a particular gateway SKU. So there are those different ones available. There's different speeds. So we can see the maximum megabytes per second of the different gateways, what it can actually support. Talks about the gateway subnet as well. So we have these documentation, but some of them are AZ understanding, some of them are not. So I have that choice. If it understands AZs, it can be zonal, i.e. pinned to a particular AZ, or it can be zone redundant. Multiple VNets can connect to the same circuit. So I create a circuit, I create authorizations that let gateways connect to the circuit. So if I had a circuit, I could have this VNet connecting to it and that VNet and that VNet. They would actually then be able to talk to each other. So if I had another virtual network connecting to the same ExpressRoute circuit, doing private peering, they could talk to each other. But the traffic would flow via the meet-me. So even if there was another VNet sitting here, so this is kind of VNet 2, and it was connected to the same circuit, the traffic would do this. So if this meet-me was 50 miles away from the data center, it was going to add significant latency. So I wouldn't do that. I wouldn't connect them using that. I would use peering. So kind of remember that key kind of point. But once I have this gateway, essentially what I'm doing is I establish private peering. So I'm actually going to go and say, hey, from here, through all of these connections, that is private peering. And what happens is the address space of kind of this side arranged down here gets advertised up to the VNet. So it will have in its routing table effective routes, hey, to get to side of 2, go the next hop. And that's actually an interesting thing about the next hop. Inbound traffic flows via the gateway. That is true. But outbound does not. Outbound goes to the MSEE. It's pretty more detailed than you need to know for the exam, but outbound does not go via the gateways. The next hop will be the MSEE. Inbound goes via the gateways. So that's kind of a key point for that. There are different things I can actually do. There's something called fast path. So this inbound connection, if I turn on fast path, then the inbound does not go via the gateway. Fast path will go directly to the resources, does some magic. There are things it doesn't support. So if I do fast path, for example, if I jump over here, it can't have user-defined routes on the gateway because it doesn't go via the gateway. I can't connect to things that appeared. I can't talk to basic load balancers, and I can't talk to private link. So that's just kind of an important point to understand that, hey, the way the traffic flows is inbound is normally via the gateways, but if I turn on fast path, then it does not, but then there's some limitations. I still need gateways. I still have to do that BGP route propagation, and it actually has to be the highest SKU. It's like the Ultra or the ERG Gateway 3 AZ. So I still need the gateway and I still need the top tier. But outbound never goes via the gateway. Doesn't need to. It just goes straight to the MSEE. There are different speeds about ExpressRoute. So when I buy a circuit, I mean, there are certain limits. I'm going to talk about premium in a second. But it tells about the number of circuits I can have. So the number of virtual networks that can connect to a circuit for the standard SKU is basically always 10. So 10 different VNets can connect to the same SKU regardless of kind of the circuit size we can see over here. But if I add premium, well, I can add more VNets to the same circuit as kind of it gets faster, this bigger connection. So there are some differences that kind of creep in between standard and premium. And again, I'm talking about those in a second, what standard and premium differ by. So it's private peering. So private peering, hey, I'm connecting IP space to IP space of a virtual network. Then what we also have is kind of this idea of Microsoft peering. So Microsoft peering are those other services that don't exist in a VNet. Now, ordinarily, these services advertise these public IP addresses out to the internet, and I connect via those public IPs. But maybe I want to actually connect to them via this private connection. Now, when I turn on, I can have both Microsoft peering and private peering on the same circuit. My provider may charge me separately. That's down to the provider. So I turn on Microsoft peering, and I get nothing. Nothing happens. Because by default, it's not advertising any routes via BGP to say, hey, take this path instead of your path via the internet. So what I have to actually create is a route filter. And then I kind of link that to the Microsoft peering. And that says, well, hey, via BGP, now we're going to advertise these services to come in via this connection. So if I jump over super quick, if I look at my, over here, so if I look at my route filters, so I'd create a route filter, and what it's going to do, if I manage the rules, I select the service communities, i.e. Exchange, SharePoint Online, Azure AD, all the different regions, and then particular services within a particular region. So I can say, hey, I just want these routes advertised through my Microsoft peering, so only these things that I have selected would go via my ExpressRoute connection. So that's really kind of a key point about that. And that's really all there is to it. Now, I do have to do a few different things. For all of these peering connections, obviously, if you notice, there's the Microsoft edge side and the provider edge side. I need IP addresses. If it's private IP, sorry, private peering, I can give it private IPs, 2/30s or 1/29. The customer always gets the first usable IP. The MSE uses the other one. I can use public IPs, kind of a waste. If it's Microsoft peering, again, I need 2/30s or a 29, but they have to be public IPs that I have to actually use for that connectivity. Also, with Microsoft peering, because it's all public IP space, I have to NAT the traffic. So when I tell it an IP space that I'm advertising over Microsoft peering, it's generally going to be my NAT servers here, which are separate IPs. That's going to NAT the traffic from that private side of 2 space over that connection so I can actually get to it. But I talked about kind of premium, ExpressRoute premium before. So what does that mean? So ordinarily, we have ExpressRoute standard. And I can actually think standard covers everything in a certain geopolitical boundary. Because I'm connecting to the Microsoft backbone network, but I can only connect to things in the same geopolitical boundary. Now these are documented. If I look at the ExpressRoute regions, it tells me at the top the geopolitical region. So North America, for example, are all of these regions. So if I have a regular ExpressRoute circuit to meet me in North America, I can connect to all of these regions, but only those regions. If I turn on premium, so if I go premium, let's pick a different color. We do gold, there we go. If I do premium, it is now global. I can connect to any region on the Microsoft backbone network. So that's really the big difference between them. Now, there are some other differences. With the premium SKU, I can advertise more routes. I think it's 10,000 routes instead of 4,000 routes. I can, if I get Microsoft buy-in, connect to Microsoft 365 services over that as well. So there are some differences between the SKUs. Let's look at the pricing details quickly. I think this might spell it out. So notice you can add on the premium kind of price added on to the cost of the standard price if I want that. I'm trying to see if it tells me what premium is. So ExpressRoute documentation tells me what premium is. Where's it gone? But it's basically that. I don't know if I'm going to find it quickly. But that's the key point behind premium is, let's see if the FAQ has it. Premium, here we go. Yep, so increased route limits. So it's 4,000 to 10,000. Remember that increased number of VNets can connect based on the speed, connecting to Microsoft 365 services, and global connectivity. So those are the things I said, so thank goodness I didn't get that wrong. But that's what I would actually kind of use that for. Now, when I'm looking at the pricing, an interesting thing is in Azure, you don't pay for ingress. So data coming into Azure, I never pay for it, but I pay for egress. If it's going out to the internet, out to another region, I pay for egress from Azure. And ExpressRoute is no different. There's actually two different SKUs. There's actually three. So there's a metered plan for ExpressRoute where I pay for the egress. And that's normally the right one for most customers. So if I look at the metered plan, you can see the metered plan, let's just say 100 megabits per second. Okay, so it's 80, why is it pounds? It must detect my accent. Some new advanced thing. But it's $110 per month. But I then don't have any outbound data included. So I pay for the outbound data, and it's telling me based on the zone. So different regions like North America is zone 1. Then it tells me what zone 2, 3, 4 is later on. There's also an unmetered plan. But for the unmetered plan, notice the price is significantly higher. So it's $575 instead of the $110. So I'm paying more, but I don't pay for the egress. Typically, you wouldn't do the unmetered unless you were constantly using, I think it's 60% or more of the constant egress speed. It just doesn't work out optimal for you. Then it's also noticed here in this unmetered something called a local circuit. Now notice the local is significantly cheaper than the standard. So what is local? Now remember when I talked about the different locations, if I jump back to this document by location, when we looked at this document, it actually had this concept of a local Azure region for some of them, not all of them. Notice Atlanta doesn't have one. But if I scroll down, for example, like San Antonio is local to South Central US, i.e. that meet me is super close to a certain region. So what the local SKU lets me do is if I use the local SKU, I can only connect to the Azure region that is local to the meet me. I can't connect to the others, but I don't pay for egress. So kind of the big point here is that local SKU. If I just need to do a huge amount of egress, but my region is local to the meet me per that chart, it's a lot cheaper. So if I have that requirement, hey, use the local SKU. So the local SKU, kind of a key point, kind of draw this out. So local only region. So that's kind of an important thing. So there is the local SKU, but I can only use the region local to the meet me per that chart. That's kind of a key point. A few other little things. So I talked before about kind of BGP. I talked about BGP is used. I have this redundant pair, this active-active. If there is a failure, it uses BGP to detect that and do the failover. Well, that BGP could be fairly slow. It could take many minutes to fail over. So there's actually something I can do, BFD. So this is basically, I think it's almost like a sub-second. So what BFD is actually going to do is this bidirectional forwarding detection. It's going to enable much faster link failover. So I can turn that on, typically sub-second. There's a failure, it's going to detect that. Another thing you might want to do is, remember, this is not encrypted. I talked about this is not an encrypted connection. It's a private connection, but it's not encrypted. Now remember I talked about, instead of just buying circuits, if I'm like big into this, I might buy kind of ExpressRoute Direct. So with ExpressRoute Direct, there is no service provider. At that meet me, it essentially becomes, so this is the meet me still. You can think about, well, I still have that Microsoft Enterprise Edge routers, but now it's really the customer edge. We have this customer edge routers, and then I have that pair of connections between them. So this is only for ExpressRoute Direct because it's just me, I'm owning the ports. So if I want to encrypt it, there is actually something I can do called MACsec. So what MACsec is not end-to-end encryption, but it's going to encrypt between the two routers, the customer router and the Microsoft Enterprise Edge routers. So basically the air of the meet me location, so as it's traveling over that, because obviously there's cables going, that traffic will be encrypted between the two routers. So again, not end-to-end, but in the air of that meet me, I can use MACsec to do that encryption. And as mentioned already, I could do a site-to-site VPN over ExpressRoute. So if I have private peering, if you think about, I've got the routers used for ExpressRoute, I could also have kind of the VPN gateways behind this and above this. And so over the private peering, I could establish a site-to-site VPN as well. So that is actually possible. Remember, you can have multiple circuits, and you probably would. So if I had multiple locations geographically distributed, I might have, let's say, Dallas and London. Let's say I had that, for example. Well, if I had that kind of Dallas-London idea, so let's say, hey, this was a global region. And let's say, hey, I had another data center here. And I had another meet me location here. I'm not going to draw different connections. Well, this would make sense, because think latency. I wouldn't want to, from London, talk to my London Azure region by going over my private connection up here, back over the Atlantic twice. That would be terrible. So I'll add kind of a local meet me. But now imagine a scenario, well, hey, this is, let's say this is Dallas. This is London. I would actually like these to talk via my ExpressRoute connections because it's got this Microsoft backbone network. Well, I can actually do that. So what we have is there's actually a feature called ExpressRoute Global Reach. And I can turn that on, and what that's going to do is essentially over that Microsoft backbone network, it's going to connect my offices to each other. So that's what ExpressRoute Global Reach does. It gives me that connection to actually go and leverage that capability, use that existing, now maybe it's a backup connection, it's not my primary one, I'm using it as a backup, or maybe that is how I connect them together. So that's hybrid connectivity, site-site VPN, point-site VPN, ExpressRoute. With ExpressRoute, I don't only have to do private peering, I can kind of do that Microsoft peering as well. there's a lot of management involved in those things. If I have ExpressRoute and I have VPN, maybe I'm doing all these different peerings, I have all these different things that maybe I have to manage. There's actually quite a lot of work I'm doing there. So there is another service that kind of takes a lot of that work away from me. And that service is Azure Virtual WAN. So we hear a lot about SD-WANs today and hey, this new world of just using the internet connection. So instead of me having to worry about these peerings and these VPNs and these express routes, well, if I think about a certain region, I can just create an instance of Azure Virtual WAN. Now what it's doing behind the scenes is it does create a managed VNet. But I don't have really any direct access to that managed VNet. It's just there. But what I can then do is if I have kind of other VNets I essentially can add them. It's going to peer them. So I can kind of do this. There were two SKUs. So I should kind of stress that point. There's a basic. So if I have the basic SKU, I can do those connections, but it only supports site-to-site VPN. So if I had a location, it supports connecting it. But that's just me getting to the VNet. And I could have multiple locations, and it would kind of connect those things together. Then there's also, let's do another color. Going to run out of colors today, I think, for sure. We'll pick that color. No, it's too similar. That's a bad idea. We'll pick gold again. There's also a standard SKU. So in addition to kind of the site-to-site VPN, it also supports ExpressRoute, and it supports point-to-site, and it kind of supports this VNet transitive, and it supports kind of multi-hub routing. Because I may have another region. So then that other region, I have another VWAN over here. It will now let me kind of connect them, and it has connections, and everything would route together. These VNets can now talk to each other. I could add another location with an express route. They can talk, they can talk, they can talk. I can have my kind of point to site. It's kind of now enabling this full connectivity between it. Now, if I don't want this kind of any-to-any configuration, I can add custom route tables. To restrict the flow. So if I don't want this any-to-any, I can absolutely use a custom route table for VNets. So I can link it to these, say, hey, I actually don't want you to talk. So I can restrict that if I want to. So that's kind of a cool thing I can do. There's even third-party NVNet, network virtual appliances that I can actually install into the managed VNet. Maybe I've got like a Barracuda, and then my branch offices may be connecting via Barracuda gateways locally into this Barracuda NVA that I've got in that managed VNet. So I can absolutely do that as well. Okay, so lots of different things. I'm trying to get my bearings a little bit. So that was all about kind of connectivity, hybrid connectivity, making all those things work. Now what I want to actually talk about is, I kind of alluded to a load balancer. Long ago, many hours ago, I talked about this load balancer. There's actually different load balancer solutions available to us. And it depends on my requirement. And again, I've got a whole video about picking the right one. Because if I think about, hey, I have these public IP spaces, public IP addresses, or maybe internal, I want to make services highly available. So how do I actually do that? There are many different options when I think about load balancers in Azure. So we get a little dot here. I want to draw up high away from everything else. Because if I think about the different types of services we might have, well, there's different requirements. Think of load balancers. What do we have? Well, I might have services at a global level, and I have services at a regional level, i.e. within a certain region. And then quite separate from that, I have some services that operate at layer 7. So things like HTTP, HTTPS, HTTP2, and I have things that operate at layer 4, i.e. TCP, UDP. So depending on what I'm doing and what I need, I'm going to have different solutions that I actually want to use for this. Watch the video. There's a lot of detail around this. Now, a key point here is I'll often combine solutions. So within a certain region, I'm going to use one of these. Then if I'm deployed to multiple regions, I'll probably have global services that point to the regionally highly resilient services. But let's start with the bottom layer for regional. So what is my solution here? So my solution here is the Azure Load Balancer. This is actually kind of a very simple service when you think about what it's doing. It's layer 4. So with layer 4, what that really means is I'm focusing on these kind of 5 tuples. And you see these 5 tuples a lot. You think about kind of the source, IP and port. You think about the destination, IP and port, and the protocol. That's really what we understand for this. So I have this load balancer. So kind of draw this big symbol. And the whole point of what this has is there's actually front ends. Now this front end is obviously an IP address. Now there's 2 types of load balancer. I can either be internal or external. I cannot mix them. I can have multiple front end configurations, but I cannot mix them. So I'm either everything is an internal front end or everything is an external front end. I can't mix them. So I have a front end IP address. And then what's happening is that traffic is coming into the load balancer, and I have a number of rules. And those rules are really deciding how do I distribute the traffic. Now for this, there's actually a number of different SKUs. And that really dictates what I can do for some of these kind of traffics and what I can support on the other end. So there's 2 SKUs. There is a basic SKU. So the basic SKU, everything has to be in one availability set. So I can have up to 300 in the back ends, but they're all from the same availability set or the same VM scale set. This is free, but it means there is no SLA. So there's no service level agreement for free. There is no availability zone support. And also it's open by default, which is very similar to the free public IP or the basic public IP. And remember, I have to use these together. So if it is exterior, if it's basic load balancer, I have to use a basic public IP. Or there's standard. So I could use that with a standard public IP. So there's a cost for this, but it means I get an SLA. I can actually support a 1,000 backend in the same VNet. Doesn't have to be the same VM scale set, the same availability set, doesn't care. So it's 1,000 instances about that. It supports AZs, so it can be zone redundant or zonal, i.e. pinned to a particular one, and it's locked down by default, so I'd have to open things up. And also it can point to either network interface cards or IP addresses. Some resources don't have a NIC. If I think about pods in AKS, they don't have their own NIC. So the idea of being able to use an IP address can actually be very powerful. I can have more support containers. But they must be in the same VNet as the load balancer. So I do get those different SKUs. So we have this front end IP address. We have the load balancer itself. And then we have back-end pools, which are made up of resources, again, from either the same virtual network or the same availability set, if it's basic, etc. And it kind of distributes to those via the rules. There were also health probes going on. So the health probe I specify as part of this to say, how do I know if a particular member of the pool is healthy? If it's not healthy, I don't want to send the traffic to it. So that's really an important thing I want to have. Now there are different rules available as part of the load balancer. So a key one is a load balancing rule. So this is kind of this hash-based distribution. So for these kind of source IP port, destination IP port protocol, creates a hash to then send it on. So based on these protocol ports, it sends it to a particular backend member. I can pick a certain stickiness. So by default, it's kind of the 5 tuples, but I can also specify a 3 or 2 tuple. So 3 tuple takes out the port. So as long as the source IP and the destination IP and the protocol is the same, it always go to the same backend member. 2 tuple is just source and destination IP, so even the protocol can change, it will go to the same backend member. So I can kind of pick that stickiness I actually want. There's also NAT rules. So a NAT rule is, hey, I don't want to distribute the traffic over multiple members. I want it to go to a particular VM and port. So hey, it comes in to this IP and this port, always send it. Maybe it's for an RDP connection, although I want to be careful about RDP to the internet. If it's standard, I can also do outbound. And this is really about outbound NAT rules and actually configuring, this is SNAP basically. So I can figure how I do outbound if it's that kind of exterior IP. One of the configurations I can do is these rules, this load balancing rule. There's a finite number of rules I can actually have. So something I can do on standard is I can do something called HA ports. So if I turn on HA ports, that's standard only, I don't create individual rules for ports anymore. It just will evenly distribute all of the flows. So this would be super useful if these were like network virtual appliances and I'm covering a whole bunch of ports and protocols. I don't want to do individual rules. So if I turn on HA ports, it will just distribute the flows over the backend port members. I don't have to now do individual rules, and I can't do individual rules. So HA ports just does all flows. I can also turn on something called floating IP. And what basically that means is I send the front end IP to the back end. Ordinarily, what the backends pools see as the destination is themselves. It gets rewritten by the virtual switch to say, even though it was sent to this front end IP, they don't see the front end IP. They think they are the target. Sometimes I don't want to do that. So what I can do is if I turn on floating IP, what they see as the destination is the front end IP address. I have to do a bit of wizardry inside the VMs, maybe add a loopback adapter for that IP so it makes sense to it. But I can actually turn that on. I can configure that if I want to. So that's really the load balancer. So the load balancer is really all about, hey, layer 4, I can create rules. I guess we can see one of these super quick. See if I jump over to my load balancer. And I should actually stress something. When I talk about load balancers, there is a help me choose. It can answer you questions, and there's actually a service comparison. So this is super useful. And it tells you, hey, look, for the load balancer, it's TCP UDP. It can do private load balancing. It's not global. It's using that round robin based on the hash, and it's Azure resources only. So it's a really useful thing. If I look at my load balancers, basically what you're just going to add in is, hey, I can have my backend pools, the members I'm sending to, and then I can have rules. Hey, yeah, look, TCP on this IP coming in, going to this port, send it. So, hey, look, it's coming in IPv4, going to this particular front end IP on the load balancer. It's TCP. It's coming into port 80. I want to send it to port 80 on these back-end VMs. And this is the health probe I'm going to use to see if they're healthy. I can pick additional session persistence. So this comes down to the tuples. So, hey, normally it's 5 tuple with none, but I could also say, hey, just do 2 tuple client IP or 3 client IP and protocol. I can turn on that floating IP that I talked about. So it would see the front end IP address, and there's also some outbound SNAT rules as well there. And also can also see inbound NAT to map particular port and IP to a particular VM. And I can do outbound rules as well. So that's layer 4. Okay. What about regional? So within a region, layer 7. Well, that is going to be App Gateway. So App Gateway is another service we have. Again, it's regional, HTTP, HTTPS, HTTP2. It is a layer 7 device. Now, because it's layer 7, it understands a whole bunch of layer 7 things. I can do things like URL-based routing. I can do redirection, redirect HTTP to HTTPS, redirect this site to another site. I can do SSL offload. It can actually go and do that decryption and then send it unencrypted to the back end, or it can even re-encrypt it and send it on. I can rewrite the entire URL. I can rewrite the request. I can do cookie-based affinity. There's a whole bunch of cool things I can do with this. There's also a web application firewall. So what I can optionally turn on is the first part is this web application firewall component to protect me from these standard types of open web application security project core rule set, CRS, to give me that initial protection. And then what happens is this App Gateway actually deploys into my virtual network. So it deploys into a VNet. And what I'm actually going to have here is very similar initially, is I'm going to have these front-end IPs. So I have a front-end IP. Now the front-end IP, it always has a public that it's listening on. Optionally, I can also have a private. I cannot do private only. What I can do is lock down the public, so it's really not being used for anything, but I can't not have it. Now, once I have the front-end IP, what I actually create are listeners. So a listener is kind of listening on a particular IP, and kind of a particular port is how that's working. Now, at this point, I can also tie into other things, like I could do things like SSL offload at this point through ports. I can hook into various certificates as part of that configuration. But for the listener, there's 2 types. So there's basic. So basic is basically everything goes to this particular rule. Anything that it's listening on this port, no matter what the FQDN, is going to go to that rule. There's also something called multi-site. And what I can do with a multi-site is I can have multiple listeners on the same port on the same IP, which normally wouldn't work. So what this is actually doing, this is actually looking at kind of the fully qualified domain name, i.e. the domain that's coming in, and I can do wildcards. I can do various characters in there to send that to a different rule. So the same port, same IP, I can actually use different rules. So hey, this is going to star.saviltech.com. Go to this rule to go to this backend set. Oh, if it's savcom, whatever, .net, go to these other ones. So I can use these different things. So this uses rules. And kind of just like the other thing, there's a basic rule where with the basic rule, it just kind of says, hey, you just go over here, send this to everything I kind of have. So it's port, go over here. I can also do a path-based routing. So with path-based, hey, if it's /blog, go to this set, because what I'm going to have on the other end of this are various backend pools again. So if it's path-based, one path could go there, one path could go somewhere else. I can also do various types of rewrite within here. So I can rewrite the URL, I can rewrite the request, I can rewrite the header. There's a whole bunch of different things I can do to actually change what's within there. In terms of the services in this backend pool, it's actually a lot more flexible. So the services in that backend pool can, yes, they can be things in Azure, but they could also be things on premises. It actually doesn't really care. As long as there's connectivity to them, site-to-site VPN or ExpressRoute, these could be kind of on-prem as well via kind of that site-to-site VPN, ExpressRoute. Other things as well, it really wouldn't matter to it. As part of that rule as well, there's a whole bunch of kind of HTTP settings that I can configure. And that's things like affinity. So hey, those cookie-based session affinity. If I'm gonna do maybe re-encryption, I can configure all of those things on there. So I have those different options. Again, there are different SKUs available for this. I think there's auto scale in the standard SKU, there's zone redundancy, zonal, but again, it exists in a single region. These are all regional resources. And again, the Azure site is kind of cool. If I go and look at the service comparison, it shows me, okay, well, App Gateway, okay, yeah, HTTP, HTTPS, HTTP2, private, round robin, Azure, non-Azure cloud, on-prem, and all these kind of nice features like session affinity, host and path-based routing, TLS offload, okay, WAF, NSGs, NSG because it lives in the virtual network, so I can use that, and that optional web application firewall. So there's a whole bunch of different things. It has the same health probes, so we can go and check is the backend pool member actually there, and I can use it. So it gives me those capabilities. Okay, so now let's kind of move on to the next kind of level of service. So those were regional. What about global? So let's think layer 4 first. Now, what I would say is for layer 4 global, there is actually global Azure Load Balancer, but at this time it's in preview, so it's not in the exam. But what that global does is it actually has an Anycast address that can point to regional Azure Load Balancers. But again, that's not going to be in the exam, but there is a video in the playlist if you are interested on that. So the solution we really have now for global balancing that's not HTTP, well, that's going to be Azure Traffic Manager. And it's really a pretty simple service because it's DNS. That's how it's working behind the scenes. So the way this is really going to work is I create a traffic manager name. So let's just say this is, I don't know, savweb dot, and it's going to be traffic manager .NET. Now that's resolvable across the kind of the whole Azure DNS service. Now, I don't want to point people to that. So on my domain servers, I might create a www.saviltech.com, which is a CNAME record, an alias that actually points to that. Then what Traffic Manager does is on the back end of this, I can have a whole bunch of different resources. I might have in these Azure regions over here. It can even support things that aren't in Azure, so maybe it's some location over here. And it has them as possible resolutions. I can even use IP addresses, fully qualified domain names, as part of that. And the way it's really going to work is, hey, I'm kind of sitting here on my machine, and I say, hey, www.saviltech.com, and I question that to my local DNS server, who then goes off and does a whole bunch of recursive resolution. So they resolve that for me. So that goes up to Traffic Manager. Now, Traffic Manager has a whole bunch of different methods it can use to actually distribute. The common load balancing one you're going to use is performance. So what performance does, based on the latency of my DNS server to the possible targets, it will resolve to the one closest to me, i.e. it would give me kind of that one, the one that is closest to me. Now, as the targets, it can actually be these Azure endpoints. So it can be Azure endpoints. It can also be external. So that could be a fully qualified domain name, an IP address, or it can actually be nested. So this could actually be kind of another Traffic Manager profile, which is one of those things. So performance is the most common. Hey, redirect me to the one that's closest to me. There are others. So if we look at the documentation, we can see there's priority. Have one as the primary service endpoint, but go to others if it's not available, because again, we have health probing on this thing. Weighted, send 50% to this endpoint, 20% to another. Performance, obviously the one, send me to the closest one. Geographic, send me to the one based on different geographies. So I have these different endpoints. These endpoints are for North America. These are for this country. Multi-value, hey, instead of returning one, return all of the possible IPv4, IPv6 addresses, and then the client can pick which ones it wants to use. Or subnet, hey, map these IP ranges to specific endpoints. And the documentation goes through kind of how all of those work. So there's all these different things available that I can leverage. Key point though is DNS. So I do, as part of my configuration, have to consider what the time to deliver the record is. Because if one of these goes away, if the time to deliver the record is 5 minutes, it's not going to go and recheck and get resolved to something different for 5 minutes. So I always have to consider that. For my layer 7 solution, it's Azure Front Door. Now, Azure Front Door is really focused around the idea that, once again, there's this massive Microsoft backbone network. And what I can think about having is, remember, we have all these different regions. And most likely I've kind of got my App Gateway in this region offering a service. I've got another region with kind of my App Gateway offering it from here as well. Maybe there's even some on-premises region that's offering the service over here. And I talked about before, also hanging off this network are a whole bunch of points of presence. Different locations that network expands to. Microsoft use it for the content delivery network. So what Azure Front Door does is essentially it adds an Anycast IP, which means that IP address is available at all of the different points of presence that is supported by here. Now, additionally, I can turn on Web Application Firewall to kind of be in front of all of those to again give me that protection from the common thing. And then it has a number of possible back-end targets as part of that Azure Front Door profile. And now this is only again for HTTP, HTTPS, HTTPS2. It's again that layer 7. So now what happens is me as the user, let's say I'm here. I want to go to the service. So I go to this Anycast IP. So I'm going to go to the one that is closest to me. Now, so that's Anycast. But then what it does is something called split TCP. Because ordinarily what happens is it would then redirect me to the back-end service. There's a whole bunch of things that happen. I have to establish a TCP connection. Then I have to establish a TLS connection. It does all this to the local point of presence, so it's much, much faster in terms of that actual connection. It can do things like SSL offload. So at this point, I can do SSL offload. It's going to actually improve the overall performance. And then I make a request. Hey, I want this block of data. At that point, it will go and take the request and get the data. It will go and do the request. It will get the response. For a much bigger chunk of data, I can do caching. So then the next person will get a better performance, and then it serves up portions of the data. So Azure Front Door is really going to improve the performance for multiple reasons. Yes, it does some caching. Yes, it's going to redirect me to the one closest that's available. Again, it's doing the health probing to check it's there. But all the TCP establishment, the TLS establishment happens close to me, not going to the back end. Then it gets big chunks of data and serves that up. So I can really focus a whole bunch of different things. If it's a back end, if it has a public IP, if it has a resolvable DNS name, I can use it with this capability. Now, what's coming out is kind of these V2 world of Azure Front Door. Now, if I actually look at this for a second, this is preview right now, but they're basically going to add some additional features. And what they're doing is they're really combining Azure Front Door with Web Application Firewall and the Azure Content Delivery Network. That CDN is kind of super useful for static, for non-changing content. So they're merging all of these things in together. And what's really happening is that premium SKU, you can see, hey, look, private link support. So I can now redirect to resources via a private endpoint that we're going to talk about. Has things like threat intelligence, bot protection, all of those kind of WAF capabilities. So you can kind of go through here, make sure you've got a basic understanding of the features of it. But the V2 really merging all these various things in together. So up until this point, we've really been focusing on making things available, hybrid connectivity. Now let's think about the opposite side of this picture. I don't want to make things available anymore. I actually want to think about maybe locking things down. So the whole idea of, hey, this great connectivity, everything can talk to each other, fantastic. Maybe I don't want to do that. Or I want that, but now I need to actually control and start restricting things down. Now, Azure Security Center is a great starting point. Azure Security Center has, based on Azure policy, some default things it can actually leverage to advise on, hey, locking things down using these capabilities. Hey, I should have an Azure firewall. There are things I can do. For protecting those public IPs, there's a standard distributed denial of service that's just inherent, but it's really designed for massive scale. There's also a paid for version, so there's a standard offering. What the standard distributed denial of service protection does is I apply it to a VNet. All of the public IPs associated with services in the VNet, it now uses things like machine learning to actually tune to what is historically seen on that. It gives me more control reporting. Hey, I'm going to start preventing these denial of service attacks a lot earlier because I've learned what is common for this particular service. So distributed denial of service, there's a standard offering, gives me machine learning based protection, more reporting, more control. But now I really want to think about really controlling things. So I have my virtual network. So I have my VNet. And remember, the whole point of this is I might have multiple subnets in that VNet. So I've got kind of subnet 1, 2, 3. And ordinarily, everything can talk to everything. I can talk to peered networks, ExpressRoute connected networks, if I don't do anything else. So I want to think about controlling that. So the way we do that is we create something called a network security group. And just like many other things we've seen, we have both the idea of inbound and the idea of outbound. And we create rules. Now these rules are really all based around that same kind of 5-tuple idea. We're very big on kind of maybe a CIDR range, an IP range, but there's also these things called service tags, which I want to talk about. A super important point though about network security groups. This is not an edge device. It's not an appliance sitting at the edge of my subnet protecting traffic. If I think about a virtual machine, the virtual machine attaches to a network interface card. It is here that the NSG is enforced. And why that matters is it means it doesn't matter if I apply the NSG at the subnet, which is how I normally am going to do it. So what I'm going to do is I'm going to link this to a subnet. It still applies to the VMs in the same subnet. It's just for management, I apply it to the subnet, but I can also link it there as well. It's just that it gets very hard to manage. So we'd rather not do that. Most of the time, we'll link it at a subnet so it's easier to manage, but we can because it actually is applied in the virtual filtering platform of the switch that makes all of this actually happens. So I link this into the NIC. It's enforced there. Ideally, I link it into the subnet. It's these whole bunch of rules. So it applies regardless of even if they're in the same subnet. Now it's created within a region, so I have to apply it to a VNet in the same region. And I create these rules. Now there are a number of them built in. So if I jump over, I'm getting a whole bunch of different tabs. Let's close some of these down. So if I go and look at my network security groups, there are certain rules built in. So if I just go and look at, it doesn't matter. I can see inbound rules. Now notice there are these 3 rules by default. So this is inbound to the VM where it has this linked. And it's got this special name here called virtual network. So anything from the virtual network to the virtual network is allowed on any port, any protocol. And remember what I said, the virtual network is the known connected IP space. So if I have a virtual network, let's try and find a big picture of one, and I've peered it to different networks and I've done site-to-site VPN or ExpressRoute and other things, all of those connected things are virtual network. That's an important point. It's the known connected IP space. So that default rule that we see there is any of the connected IP space can all talk to each other completely unrestricted. So that's kind of a default rule that's there, inbound. Then it also always allows the Azure load balancer to talk to it, so it can do health probing. Everything else is denied. So that's coming in. Outbound rules, the stuff going out of the NIC, it says, hey, look, again, everything within the VNet is allowed. Everything out to the internet is allowed, and this is stateful, so the response will be allowed back as well. everything else is denied. So what the basic rules basically let you do is to say, hey, anything within the VNet in and out, I can go out to the internet, nothing else can come into me, except the load balancer for probing purposes. And then what I would do is I would add additional rules. So the source, again, can be IP addresses or this weird service tag thing. I pick the port it's coming from. Destination, again, could be IP addresses or can go to kind of this virtual network. It's an inbound rule. If it was an outbound rule, the source can be IP addresses or the virtual network, but now the destination can be a service tag. So I talked about the virtual network as a service tag already. There's a massive number of them. And think of a service tag as really just representing different Azure services. I talked before that really the Azure services, I can't remember where it was on this board anymore. I think it was when we talked about Microsoft Peering, are really just a bunch of public IP addresses that it advertises out to the internet, a huge number of public IP addresses. Well, maybe in my rule, I want to allow it access just to storage in South Central US. There is a CSV file I could go and get, but I don't want to have a load of IP addresses that update periodically in my network security group rule. So a service tag is basically the IP CIDRs per service. And often it's service-region. So they've created these, so in my rule, I don't have to say this IP, this IP, this IP, this IP for storage in South Central. Instead, what I can very nicely do is, hey, yeah, look, there's service tags for, look at all of the Azure services. Storage, there it is. And I can use this only for outbound because storage doesn't establish connections into a virtual network. Whereas something like Service Fabric, well, that does in and out. So it tells me which direction that service tag is usable. So now in my outbound security rule, I could say, hey, I want to allow access to, no, it says internet, everything that is not my virtual network, which is the known connected IP space. I could say kind of these standard global things. So I could say, okay, all these services, I could say storage, or I could say storage dot just South Central US. So I could pick a very particular one and just allow connectivity to that. It knows it's a custom service, and I can here have a certain port I want to use. If it was a certain type of service within the storage account, maybe SMB, I would pick a certain one. I can pick the protocols. So I create the rules to basically specify the types of connectivity I want. So yes, I can use CIDR ranges, because that would be super useful, the CIDR range, if what I want to do maybe is say, look, subnet 1 is maybe my DMZ. So I'm going to allow in from kind of the internet 443. But I would block that to all of my others, and that would be the default anyway. And then maybe I'm going to allow these to talk and these to talk by doing the different CIDR ranges in my rules of each of these subnets, but I don't want this to be able to talk. So I could control all of that just by creating these as the NSG rules, and then I would link it to each of those different subnets. So the NSG is all about, hey, I create the rules, realize I have to link it to the subnet for it to take effect. It processes the rules. Now, the other thing I can do is on this NIC, I can actually tag it. So we have these things called application security groups, which is really just a tag. That's all this thing is. And then in my rules, in addition to CIDR and service, I can put in a tag. So if I look at the virtual machine, what I can do is firstly, I can create these application security groups, which are nothing but tags. So I've got one called quarantine, SQL VM, web VM. I have two because they are regional. I can only use the app security group in the same region that it is created. Then what I could do on a particular resource, if I go and look at my virtual machines, let's look at my domain controller, and look at the networking, over here, if I look down here, we have this Application Security Group tab. If I select it, I can configure app security groups from the same region. That's why there's only one web VM. So I could add that tag to this network interface card for this virtual machine. Then it doesn't matter about the CIDR ranges. Then in my network security groups, instead of having to worry about what IP range it's in, I could absolutely, as part of my rule, say for things like, okay, so for my inbound rule, is that my South Central? Make sure. So make sure it's the same region. In here, for example, now I could add a rule. Instead of worrying about the CIDR range, I'll say, hey, look, I want to allow my web VM to be able to talk to my SQL VMs. And I would put in the right port for SQL. Was it 1433? Not 100% sure. But I can specify that instead. So now it doesn't matter where it exists. It's just based on that tagging I'm actually doing on the NIC itself. So application security groups are actually super, super powerful. Then I can think, well, okay, so that's controlling things. So that's fantastic. I really want to make sure I'm doing that. But now I might think about controlling connectivity, because there's other types of service. Imagine, for example, I had kind of a storage account. So I had storage account 1, and maybe there's a storage account 2. Remember, these have their own kind of firewalls as part of them as well. Maybe I want to restrict the storage account to only allow this VNet in. But I can't do that because this is a private IP space. It would be meaningless to that firewall. So what I can actually do is I can create something called a service endpoint. So what service endpoints let me do, so I can add a service endpoint for storage in South Central US. That does really two things. Firstly, it now gives me a better route to all of the storage accounts that are in South Central US. So there's a preferred optimized route. It also now makes subnet 3 in this VNet, let's call it VNet 1, a known entity to firewalls that are in the storage account of South Central US. So in this particular one, I could actually now say, hey, yes, I'm going to allow VNet 1 subnet 3. That's allowed to pass through. So now this can actually talk to that particular instance because I allowed it on its firewall. So that's what service endpoints do. So I can go in on a virtual network, I can select the services I want a service endpoint for. It gives me an optimized route, and I'll see that in the effective route table. And I showed you those earlier. You might have noticed there was a whole bunch of IP addresses. Well, those same service tags represent the IP addresses of the service. It now has an optimized route. It knows to use the service endpoint route, and it's now a known entity. I can enable it on the firewall itself to just let that through. So that's making it a known. Maybe though I don't want any public connectivity. Now that service endpoint is only usable from that subnet. I can't go and access that from an ExpressRoute, a site-side VPN, or anything else. So the other thing I can do is say, hey, I have another, let's say storage account 5. I can add something called a private endpoint. A private endpoint is an IP address from the network. It's going to get it from whatever the CIDR range is that represents that particular instance of that service. In this case, storage account 5. So now there's no public connectivity to it. I can get to it through this private endpoint. Now it's just an IP address. So any network peered to this VNet can use that address. any site-side VPN or ExpressRoute can get to now this storage account through that private endpoint. Now there's also some special DNS required. And I'll talk about that in a second. But I do have to be able to resolve the name to this private IP instead of all the public ones. It's still going to spit out there, they just won't be usable. Now that's if it's a standard built-in kind of PaaS service to Azure. Nearly all of them support private endpoints today. What about if I had my own custom service? So I have some kind of resource. What I have to do, I have to put them behind a standard internal load balancer. And then I add the private link service in front of that. And then this can have private endpoints that point to that. And I can have multiple private endpoints to different things. This is all flowing in kind of this direction. This is getting me to a service. It is getting me to the storage account, to the SQL, to these things that kind of distribute. So if I wanted to add my own service via a private endpoint, I have to have a standard internal load balancer. I have to add the private link service to that, which does the NAT, which means these could actually be in a VNet and they could have overlapping IP space. This actually does the NATing. And then I project a private endpoint into that particular subnet, which again is kind of usable everywhere. Now, the DNS has to work. Now, by default, it can work with an Azure private DNS zone. It will create it for me and link it to the VNet. But what we'll see is there's a whole bunch of new private link dot domains. So we'll see, hey, let's see, for SQL, instead of just being database.windows.net, now it's private link.database.windows.net. And what happens is an alias is now created, so the things in database.windows.net now actually resolves to the private link.database.windows.net. I can show you this. So if I open up so I've got one of these. So if I look at my private link quickly, I've actually got a couple. But I created some private endpoints to storage account. So I've got a blob private link resource, a files private link resource, a cloud endpoint, etc. So what happens is ordinarily, if I look at my storage accounts for a second, if I can find storage, which maybe I've removed from my menu. So just type in storage. I created one with private links. So I've got this private link demo. And what we can see is on this, I have a whole bunch of those private endpoints I've added. But what I'm looking for, this is networking. There's those firewall things I could add if I had the things, but I've got my private endpoint connections. And you can see I've added 2. And normally the name for this service, if I actually go through, if I look at my endpoints, well, my name would be this, sa private link.blob.core.windows.net. I'm kind of looking here. But if I actually open up terminal for a second, and if I do an NS lookup on that, what we'll see is because there is a private link, let's get rid of the HTTP part, don't want that. It now actually has an alias over here, and that will actually resolve, if I'm on a VNet that can resolve that DNS record to the private IP. Now this is just a public one because I'm not on a network that has that DNS, but it would actually resolve to the private IP instead, and then I could get to the service. So that's what's kind of happening. There's a whole set of special DNS happening behind the scenes as well that I actually need to manage. App Service also supports these. When I think about App Service, it's a little bit special just in terms of kind of the zone it's going to use. But once again, you're going to see it go ahead. And in the DNS, we'll see, hey, look, We have a CNAME for private link.azurewebsites.net, so we will get that over there. But if we think about, remember that the DNS is kind of a key thing, because it has to be able to resolve that. So if I'm very simple just in the VNet, it will create an Azure private DNS zone, it will create the private link.blob.core.windows.net, whatever that is, and it will use it for resolution, and I'm good. If I'm trying to use it for on-premises, I either have to create a private link.blob.core.windows.net and add in the IP. Never ever add for the non-private link. You'll block access to all of the other services that are blob. Not a good thing. Or I could add kind of a DNS resolver, and I go into that in detail. But DNS is super important. I have to be able to resolve to the private link alias to be able to get to the service. Now, let's talk about app service for a moment. So app service, remember I create an Azure App Service plan, and then that can have multiple apps inside it. Now each app can push a private endpoint. So each individual app would have its own private endpoint. But that's all about getting to the app. What about if I want the app to get to things in the virtual network? So there's three options for that. Maybe the superior one is something called regional VNet integration. So with regional VNet integration at the app service plan, not per app, so you have this regional VNet integration. It basically takes over a subnet and it projects these phantom network interfaces into it, through which it can go and get to things. It has to be in the VNet has to be in the same region as the app service plan, hence regional. But it can then go and get to things on kind of any connected network. Peered networks, ExpressRoute, that gives me access to anything. If that is not an option, another model I can do is it can establish a point-to-site VPN connection out to obviously some gateway. That could be in other regions at that point, but it doesn't work with resources like service endpoints or connected over ExpressRoute. It's really just that. I guess there is a third option. There's something called hybrid connections. And that's really using things like Azure Relay that I might use on premises. It establishes an outbound connection to the relay service, and now it can get to anything on that network. So I could use that for like on-premises connectivity as well. So these things, the regional VNet integration, the gateway, is the gateway required? I think it's called gateway required integration, or the hybrid connectivity enable the apps to get out to whatever that is connected to. So that's kind of a key point about that. Okay, coming up to the end. One more really big service. So that's NSGs. The next kind of thing I can think about from locking things down is Azure Firewall. Now I drew a picture of this kind of already. This way back. My board's getting so big now, it's going to start crashing, I'm sure. I deploy this into its own subnet, Azure Firewall subnet. It has to be, I think it's a /26 minimum. And then I just use user-defined routing to send traffic to it. It could be 0000/0 for everything to go via it. I could send particular things. But the whole point is I'm going to use route tables and that user-defined routing to send things to my Azure Firewall. It has public IPs. So it can also get out to the internet, it can snap the traffic for me. It's very good at east-west traffic kind of management. It can accept inbound as well. It's not as good as something as like App Gateway, but I can do that. So remember, the whole point of Azure Firewall then is, yes, I have my virtual network. I'm going to create this Azure Firewall subnet that only it can use, nothing else can deploy into that. It's going to be this /26 minimum. And into that, it's deploying its appliances. So it's creating these multiple appliances. And the primary thing it's going to do initially is there's going to be this internal IP. That's kind of balancing between those. And that's the important part, because all the other subnets are going to UDR to route traffic kind of through there. And it can be peered as well. I could have another VNet multiple peered, and it can use that internal IP as its next hop as well. I can do all of those things. And the key part of what I'm going to do with Azure Firewall, there's two SKUs. So I can think about there's a standard SKU and there's a premium SKU. So the premium SKU literally just came out. I literally just released an 85-minute deep dive video on this. There's a whole bunch of features. I am not going to go into them, but understand sort of the things it can do. It's built in HA, availability zone support, all these different types of filtering and monitoring. Premium primarily adds, really I think about it as three key features. I can do TLS inspection. I have this IDPS, intrusion detection and prevention system. So I'm looking for particular types of headers, things in the header, but it's not really stateful. And I can do URL filtering. So instead of looking just at the fully qualified domain name, I can look at the path as well. And I can use that path as part of web categories. Web categories is a standard feature, but with Premium, I add that ability to use the path as part of the category, a news site, a search site, etc., etc. So Premium, I'm really adding that kind of TLS inspection. And watch my 85-minute deep dive if you want to know all about these things. I have the IDPS and URL filtering. So remember, URL is fully qualified domain name plus the path and kind of HTTP, etc., etc. And what I do is this is really getting, I think, upset the size of this whiteboard. If this crashes, it's not my fault, it's someone else's fault. What I do is I create a policy. Now, there are classic rules that I apply directly, but we try and stay away from that now. The Premium can only use policies. So I create a policy. I can link one policy to a particular instance of Azure Firewall. And then I have rules. And there's really three types of rule. There are NAT rules. NAT rule is all about, hey, I've got this inbound traffic coming in to one of those public IPs it has. I want to do DNAT. And I'll show these in a second. But it's basically, hey, coming into this port and this public IP, send it to this backend member. Very, very simple. I can do network rules. So network rules, we really think about as layer 4. So hey, TCP UDP is kind of those 5 tuples. Again, source IP, IP groups, which are just groups of IPs I define in Azure. Ports, I can obviously use the CIDR ranges. I can use the service tags again. Those service tags we used in the NSGs. It's about allowing, disallowing those types. Then there are application rules. So application rules, as you're going to guess, is more about layer 7. So here I can still control, hey, who it's coming from, who is the source. But now I can control it based on, hey, what's the fully qualified domain name? What's the fully qualified domain name tag? A fully qualified domain name tag are just well-known MS services that they are defining that maybe use different fully qualified domains. Windows Update, Windows Diagnostics, they create those for you. If it's Premium, we use gold again for Premium, based on the URL. And then I can also do it on kind of these web categories. But then once again with Premium, I can also include the URL to help distinguish that, whereas the regular standard is really just that fully qualified domain name. So I have those different things I can actually do. I'll show it to you quickly. So if I jump over to my Azure Firewall, super close all these down again. So my Azure Firewall here, basically, I don't configure anything here. This is premium, so I can't do classic rules. All I can really do is link a policy, one policy. And then in the policy, that's where I can define the DNAT rules, which say about inbound. Say coming from these places, which is home base is an IP group, go into this port on this protocol, redirect me to, when it's going to this public IP on the Azure Firewall, over here. So go into this public IP on this protocol, this port, from this IP group, which is a bunch of IPs. I want to send it to this private IP on this port. So it's just sending to some backend member. A network rule, well, hey, again, who it's coming from. So I created an IP group of the IP spaces of my VNets. And in this example, I said, hey, from the IP space on 3389, if it's TCP going to the same group of IPs, allow the traffic. It's a very simple port, protocol, destination, allow. And then app rules, these are the richer things. Here I'm saying things like, hey, based on, let's look at one of these, coming from a certain IP range, so this was my West Central VNet, I've done a rule based on web categories. And because I've got premium and I've got TLS inspection, even if the URL changes, I'm giving it access to these types of sites. And this is a continuous daily updated feed coming in for this. But there are also rules where I could do based on fully qualified domain name tags. So these are the popular services that Microsoft have defined. I could also do it based on the URL. I can have those as well. And if I looked at the network rules, let's look at one of these quick. You could see I could also have service tags. Those same service tags I could use as well, because that's really a layer 4 type thing. It's okay to have those. And then again, TLS inspection, threat intelligence, those looking at all the different signals. There's a massive different signatures it's using to kind of leverage those malicious IP addresses. Sorry, I'm talking about IDPS, the signatures. IDPS, all those signatures about detecting, hey, these types of malicious types of things in the header. I can really control and lock those things out. So really powerful capabilities. I'd often use it with, I'll still use NSGs for some of that micro-segmentation, but I can use this, kind of that layer 7 is extremely powerful, something I cannot do with NSGs. And then really the final thing is understand the monitoring. There's network insights, there's a whole bunch of different things that I can leverage to understand this connection monitoring. I can have agents deployed and do rules to go and check there. If you go through that learning, it goes through all the different resources. A really powerful one is Network Watcher. So Network Watcher gives me insights into a lot of that traffic. And when I talked about these NSGs, one of the things I can actually turn on is something called NSG flow logs. And I can kind of turn that on, and these go to a storage account, and then optionally I can kind of send it to a log analytics workspace. And then if they go there, I can do something called traffic analytics. And traffic analytics gives me this visual kind of goal, showing me most common people talking, hey, malicious traffic. I can see the most, huge amounts of detail through that, but I have to kind of go and turn that on. So I have to have NSGs, and then I can use all of this is kind of part of this Network Watcher component. So Network Watcher is very powerful. Opens up a huge set of functionality, but really getting, the flow log is not the data, but it's, hey, it's from this source to this destination, these flows. It's capturing that data. And then I can do this traffic analytics, which is part of the Network Watcher. If we go and look at Network Watcher, just to give you a really quick idea of some of the functionality. So I've got my Network Watcher. And here you can see, hey, look, I can look at the topology. I've got connection monitoring where I have those agents. I can see, is the connectivity working? Is it failing? I can validate things like IP flow, NSG diagnostics, work out what is the next hop, what are the effective security rules, and I kind of showed you the effective routing. You can look at the effective security rules. I can see that on the NIC as well. I can capture packets. I can turn this on a per VM basis if I'm doing like some deep troubleshooting. I can turn on the NSG flow logs to actually go and capture those. And then from that, once I've got those, I can do traffic analytics that then gives me this fantastic kind of visual view of, hey, these are the most common things talking. I can do it via a map. I have things like network insights to see load balancers. There's just a mass of things. Go and look at these. Understand kind of the key things you might use to troubleshoot, but super, super powerful. Just so much to cover, but this is kind of where we are. I don't think I can actually zoom out anymore. I don't know if I can fit. Oh, there we go. So there we go. We fit it all on the board. So this is what we covered. Obviously a huge amount of stuff. It's done that weird browser thing. There we go. I hope this was useful. Go through the docs, see the learning. Again, my playlist, I go through really all of these things in detail. Now there might be, I don't know, how many hours of content is there? Maybe that would be 8 hours of your life. But I think it will help you. But this was kind of the summary. Maybe watch this before you start learning to put everything in a picture, then you might link it together as you go deeper dive. I would definitely maybe watch it. I don't know how long I've been recording for. 3 hours now. My voice says 3 hours. Maybe watch it just before to cram some last minute knowledge in. But super good luck. Don't worry if you don't pass. Everyone fails things sometimes. It'll tell you at the end where you did kind of weaker. Go and redouble your efforts and you will definitely pass next time. Believe in you. But please, this was so much work. I really would appreciate if you would subscribe, definitely like. And until next time, take care.